Hello everyone. Thank you for joining us today. I'm Renata Kalnunene, Marketing Project Manager at MedDream, and welcome to our MedDream Integration Use Cases webinar. Today we have a dedicated webinar to MedDream Universal DICOM Viewer integration with ScanFlow's intelligence hanging protocols. And soon you will see our guest speaker's presentation, and of course the most interesting part, live demonstration. Also today we have Marius Šadauskas, our system integrator, who will introduce how our collaboration started and how it is going. So as you know, our webinars are being recorded, and after the webinar is finished, in a few days, you will receive the video recording and the presentation file of the webinar. So I'm going to read the agenda. So as I mentioned, introduction by Marius, how our companies started to collaborate, how much it took to integrate our product and to prepare this demo for you. Next two parts, presentation and live demonstration, will be questions and answer part. So I invite you through all the webinar, write your questions in the question and answer section, and I will collect all the questions and read in the end of the webinar. And our speakers, Reid and Marius, will answer them. In case it's not the integration related question or we cannot answer the question right away, we will add these answers in the presentation. As I mentioned, will be shared with you later. So, as I mentioned, our guest speaker is Dr. Reid Portnoy, CEO and also co-founder of ScanFlow. He is going to tell more about himself in his presentation. Also, my colleague, Marius Šadauskas, who is always a part of our integration webinars. He is going to introduce this collaboration and help in the question and answer section. So Marius, please go ahead and introduce our partners for today's webinar.
Hello. I hope you can hear me well. I hope
Yes.
you have a good day or evening or the morning. So on our today webinar, we have a ScanFlow company, which is AI-enabled radiology workflow software, which delivers hanging protocols across different modalities like MRI, CT, X-ray, ultrasound, and others. And this, in principle, helps the radiologist to save the time and to see the studies, open it in the viewer in more structured, more, let's say, well-displayed way, and doesn't need, to waste their time to drag and drop all the series to the correct viewports and so on. This ScanFlow integration and these intelligent hanging protocols is, I would say, a supplement to our MedDream existing hanging protocols, because when you are using the MedDream Viewer with our existing hanging protocols, which, by the way, is also always improved, constantly added new functionalities and so on. So you can also have the ScanFlow hanging protocols enabled, and in principle use both of them depending on your needs. Regarding our collaboration, so I would say this is a very, very good example, because our collaboration with ScanFlow started this year in ACR show. I think Vyacheslav was the person who had in contact with Reid. And in principle, we had only a few face-to-face and online meetings during which we have presented the MedDream Viewer, the integration options. ScanFlow presented their solution and did the integrations and integrated their solutions into our. And this is the example how effectively we can achieve the results if both parties, are working together constantly. And in principle, just in 2 or 3 months after the initial meeting in ACR, we have a working product already. So in this webinar, Reed will present their solution and demonstrate the integration with the MedDream Viewer. So I'm very excited, to see this, and I wish you all the great and informative webinar, and I hope it will be useful for you. So Reed, I am passing the word to you.
Thank you for the introduction, Renata and Marius. I'm going to pull up the PowerPoint presentation. I'm so excited to be able to talk about ScanFlow and our integration with MedDream. We are grateful for the opportunity to discuss how ScanFlow will improve the workflow for radiologists on a per scan basis. The high volume and complexity of cases a radiologist reads on a day-to-day basis demands maximum reading efficiency. As a practicing radiologist, it became apparent that manually organizing the images every time I opened a study was leading to an obvious inefficiency in my day-to-day workflow. And this is why we created ScanFlow. But I wondered, am I the only one that realizes this? Am I the only one that has this inefficiency on my day-to-day workflow? So I asked colleagues within my practice and even globally at ECR in Vienna, and they face this issue as well. Everyone agreed that this is an extremely overlooked workflow bottleneck that radiologists constantly deal with. 92% of surveyed radiologists repeatedly manually organize their hanging protocols for their imaging studies. And before I move forward, I just want to give a brief definition of what a hanging protocol is. A hanging protocol takes into account modalities such as MRI, CT, ultrasound, X-ray, anatomy such as abdomen or brain, and clinical indication to produce images consistently for the radiologist so they can read more efficiently and more consistently. And it's worth noting that, for example, the hanging protocol for an MRI brain would be different based on clinical indication. For example, an MRI brain to evaluate for stroke versus evaluating for a brain tumor or evaluating for demyelinating disease such as multiple sclerosis. All of these clinical indications, all these modalities and anatomy are MRI brain, but the hanging protocol would be different because these radiologists like to read each of these types of indications differently. And that's where the complexity comes in. Rigid and misplaced priors can lead to 10.85 minutes lost per shift per radiologist. If we look on the left side of the screen here, we can see there are multiple imaging viewports that are absent, and you don't see any of the images. This leads to the radiologist needing to manually organize by looking through all the sequences and putting the sequences where they like it. If you look on the right after using ScanFlow, you can see the workflow is much more frictionless and streamlined. All of the viewports are filled and everything is organized the exact way the radiologist wants it. And just to be clear, we do not tell the radiologist how they should look at their studies. The radiologist manually, the first time they open a study, they will say, okay, for this MRI brain, I like having these sequences this way. And then every time after that, ScanFlow will deliver consistent hanging protocols for that radiologist. But why do these hanging protocols break? And the main reason is that the same sequence has many different labels. You have T1 vibe arterial, you have vibe art phase, you have lava arterial, and you have lava 30 seconds. All of these sequences are named differently, but they are actually the same sequence, a post-contrast arterial phase. Why does this happen? Well, there are multiple MRI scanners within an institution. These MRI scanners likely produce different sequence labels for the same sequence, whether there's different manufacturers, if there's an updated sequence name, if the institution updated the sequence name. There are numerous factors that play a role in these inconsistent labels. And think about where we are at with radiology, especially teleradiology. One radiologist may be reading from numerous hospitals within one country. And if that's the case, they are definitely reading from different MRI scanners and different protocols itself, and they will always have inconsistent labeling. And this leads to a hanging protocol mismatch, and they will have to manually rearrange their sequences. ScanFlow handles this inconsistency and makes sure the radiologist gets delivered consistent hanging protocols every single time so that they can be efficient. 86% of surveyed radiologists experience workflow disruptions due to inconsistent hanging protocols. This is a well-known workflow bottleneck for radiologists across the globe and leads to radiologist burnout and medical error. Again, 10.85 minutes per shift on manual adjustments. This is such an excessive amount of time spent on organizing when the radiologist should be focused on diagnosis. And the financial impact is immense. Repetitive manual adjustments can cost hospitals up to $117,000 to $340,000 per radiologist per year based on medical reimbursement rates and how fast the radiologist is reading. So it's very obvious that inconsistent hanging protocols waste time, reduce accuracy, and cost hospitals millions annually. So we have the ScanFlow intelligent solution. Our enterprise-grade solution adapts to any vendor, modality, or radiologist. We input the DICOM metadata, the modality, anatomy, and clinical indication into our ScanFlow engine and output a consistent, personalized hanging protocol. We are transparent and auditable. Yes, we are AI enabled, but our code, there is no black box. We know exactly what our code is doing every single step of the way. That way we can deliver consistent hanging protocols to our radiologists without fail. We are vendor and platform agnostic with cloud and on-prem deployment. We want to be as flexible as we can for everybody. And our intelligent contextual matching of DICOM metadata is a plug-and-play interaction. We have a short implementation phase, and after that, the radiologist is ready to go with zero training needed. We are built on principles designed for clinical trust and efficiency. Our seamless integration has long-term radiologist-centered performance. We have instant usability, and again, zero training. This is extremely important. We are built by radiologists for radiologists. We do not want to add another layer of training for radiologists. We want this to be a smooth transition so they can get to diagnosis. We are one workflow across every imaging modality: MRI, CT, ultrasound, X-ray, breast imaging, such as mammo and tomo. We have cross-institutional compatibility. Again, this is so important, especially where we're at in healthcare right now. One radiologist usually now reads from numerous hospitals within one institution. And so one institution may have 15, 20, 30 MRI scanners, all with different inconsistent labeling of the same sequences. And that leads to consistent breakdown of hanging protocols. And ScanFlow makes sure that that goes away, and that's solved, and radiologists can read more efficiently, no matter how many different hospitals they read from. And this helps makes our product scalable. And to go through our system architecture, we have the server, which stores our DICOM images and series metadata, the viewer, MedDream, which calls ScanFlow API upon study selection, and our protocol library, which is institution specific. So one large hospital institution will have specific rules by modality, anatomy, and diagnosis that are based on that radiology department. Once the radiologist opens a study, it goes to our intelligent hanging protocol engine, where there's our DICOM parser, our matcher, our layout builder, preference engine, and our protocol mapping index. All of this occurs in less than 1 second. The radiologist will not even know ScanFlow is even part of the process until they realize that their hanging protocols are more consistent. And the output, the correct hanging protocol, so the radiologist can focus on diagnosis. And just to go through our API sequence, we have the radiologist will open the study in the work list. The PACS DICOM Viewer will call the ScanFlow external API. ScanFlow will query the metadata, reconcile the information, validate the hanging protocol, and then create an output of the consistent hanging protocol for the radiologist. And again, just so we're all on the same page, we want the radiologist to do what's best for them. Radiologists all train different and practice differently. So we want the radiologist to have the hanging protocol that works for them, and we make sure it's consistent every single time. This is a workflow that wins for everyone. It's an impact on radiologists with instant personalized layouts, zero friction, total focus on patient care and accurate diagnosis. The impact on hospitals is immense. We can save 47 to 80 hours per radiologist, which can unlock a value of $9 million to $26 million in value for these hospital institutions in a 77 radiologist practice. And the impact on patients. Radiologists having consistent layouts lead to 1, faster turnaround times, and secondarily, higher diagnostic accuracy, reduced errors, and safer patient care. The KPIs that we look for are 1, the radiologist experience. Like I said, we're built by radiologists for radiologists. Our North Star is radiologist satisfaction. We want them to feel good using ScanFlow. We want that to be a smooth experience so they can reduce cognitive load, reduce the number of clicks per scan, and reduce workflow interruptions. All of this will lead to increased diagnostic confidence. Operational efficiency is our second North Star. Time saved per study. This is the quantitative value that we are looking for. We want to reduce the amount of time it takes for a radiologist to have to organize their sequences and then reduce the amount of time it takes to read a study. We want to increase the amount of studies per day given the increased volume that radiologists face on a day-to-day basis. And then our quality metrics. Percentage of studies configured to match radiologist preferences, consistency across all modalities and protocols, and dollar cost savings calculated using institutional reimbursement rates. And we have our executive leadership, myself, Dr. Reed Portnoy, co-founder and CEO, Victoria Ellison, co-founder and COO, and Dr. James Consuto on our clinical advisory board chair. If you're ready to modernize your imaging workflow and you want to explore a partnership with ScanFlow and MedDream, please use the QR code below. And at this point, we will now shift towards the live demo portion of today's webinar. So as we shift gears to the live demo portion, we could just look at the work list quickly. So we have some CT chest, MR abdomens, MRI brains. And the point I want to get across here is the modality that causes the most inconsistent hanging protocols is 100% MRI. And from MRI, specifically MRI abdomens and then MRI brains. So I wanted to make this live demo high yield and focus on the protocols that break the most. So we're going to focus on MRI abdomens, the brain, and then we'll do a CT. We'll do some CT chest. So we're going to open up a study for MRI abdomen. And first, we're going to go to the standard default. So this is without ScanFlow. And you can see here that we have an empty viewport in the bottom left. And we have our FATSAT, we have our pre-LAVA, we have our coronal T2. So as the radiologist, when I open a study and the hanging protocol breaks down as an inconsistent, I have to now go, all right, well, I'm looking for the coronal T2. Okay, that's there. Where's that MRCP? Okay, the MRCP is here. Where's the post-contrast? All right, here's one of the arterial phases. And oh, here's the pre. So this is what the radiologist has to do every time they open a study if the hanging protocol breaks. Now, if we have ScanFlow, we can come right here and immediately we can see all 4 image viewports are correct. We have the coronal on the top left. We have the MRCP on the top right. We have our out of phase on the bottom left. And we have our SAG T2 on the bottom right. Now, before we move forward to the next patient, right, because what's important with ScanFlow is not the protocol itself, but the consistency across inconsistently labeled DICOM metadata. So if we look on the top left, we see coronal T2 SSFSE. We see this 3D OBL MRCP RT hypersense, out phase colon 3D ax lava flex, and then bottom right SAG T2 SSFSEBH. I know that these are a lot of words and letters to memorize, but we're going to go to the next patient and show how this can be labeled inconsistently, even though it's the same sequence. And now we can come here. And if you remember before, it said T2 coronal SSFSE. Now it says T2 coronal haste. Before it said MRCP, OBL, colon, a lot of words. Here it just says 3D MRCP BH. On the bottom left, it says T1 axial out of phase. That was named differently as well. And then we have our T2 SAG haste as well, which the T2 SAG was there, but there were other words in there making it inconsistently labeled. So on this hanging protocol, all 4 of these were labeled differently, but because of ScanFlow, they were able to stay in the same position. Now, if we juxtapose that with our default protocol, it looks something like this. So this is completely broken. We had a coronal here, it's gone. We had the MRCP, now it's a DWI. We have an empty space here, and the sagittal is not there. Now it's the axial FATSAT. So all 4 are wrong in this case. So what do we have to do? All right, so if I'm the radiologist and this happens, I have to go, okay, here's my T2 coronal. Where's the SAG? Okay, here's the SAG. All right, where's the MRCP? Okay, here's the MRCP. And then where's the last one? Okay, looking. Okay, this one works. Bottom left. So this is what it takes, what the radiologist has to do every single time the hanging protocol breaks. Now we'll just move on to an MRI brain. Same thing here. So we have our AX stealth post reformat. We have our SAG T1 stealth, our axial T2 flare, and our coronal T1 stealth post reformat. So these are all post contrast sequences 1, 2, 3, and this is an axial T2 flare. Again, if we go to the default protocol, this is complete. All of it is broken again. Same thing. We have an empty viewport here. But what's most important for us is checking to make sure that all of this is consistent across the next patient. So we will go to the next patient for the MRI brain with and without contrast. And we have our axial postcon here, our sagittal here, our coronal here, and our axial T2 flare here. And now if you notice, now it says axial 3D FSPGR reformat. All of these say FSPGR, which is different from what we saw before on the previous patient. And the same thing, the AX-T2 flare FS post was differently named as well. So all of these, again, inconsistent, labeled differently, but now with ScanFlow, it doesn't matter. The hanging protocol will not break, and we'll have consistent hanging protocols for the radiologist. And again, just to be clear, this is what would happen if the hanging protocol broke. We would have these random sequences, or get backed up from what the manual hanging protocol system was with MedDream. And you'd have to search for, okay, here's the axial that I wanted, here's the sagittal that I wanted, here's the coronal, and where's that post flare? Okay, there it is. And that's what the radiologist has to do every time. So now I know you must be thinking, oh my God, he just keeps manually organizing every time. Like, I get the point. Well, I just did this 3 times. Imagine a radiologist having to do this 50 times a day. And this is the burden that radiologists are dealing with on a day-to-day basis. And this is what pushed us to create ScanFlow, to make radiologists more efficient. And now, we have a CT example. Just going to go through this a little more swiftly. So here again, so as I said, MRI modality is the most likely modality to have broken hanging protocols, but it 100% happens with CT chest and SAG chest with CTs as well. So we have our axial chest soft tissue window here, our sagittal soft tissue window, our axial chest lung, and our coronal chest soft tissue window. And now we'll go to the next CT chest. And again, for this one, for the CT scanner, if you notice, the sequence labels are actually pretty similar, and just showing that ScanFlow works extremely well with CT as well. And just to point out again, if this is ScanFlow chest CT, if we go to standard default, it could look something like this. We have 2 empty viewports, we have the scout image up, and we have the axial lung in the wrong position. So again, what would the radiologist have to do? We'd have to manually organize it here, put this here, put this down here, and put this here. And this is what radiologists deal with on a day-to-day basis. And we're hoping that ScanFlow can reach the radiologists all across the globe and help them read more efficiently and deliver better patient care. And with that, the live demo is complete, and we're going to move over to question and answer.
Thank you so much, Reed, for your presentation and your really impressive live demo. So everybody saw how it makes difference, ScanFlow and radiologist daily life. So I'm going to share the questions. Now you should see my screen. So the first question, does the ScanFlow hanging protocols replace manual hanging protocols rules, or will this be part of the configuration and used in parallel?
Yeah, so from our MedDream part, I will just comment quickly. So as mentioned it before, it is possible to use your created hanging protocols, which you create using the MedDream hanging protocols version 2, which is the newest one, and we recommend to use it. And you can have the ScanFlow hanging protocols also. So in principle, you can have both of them working, and it's not like a replacement, that if you have one, so you will the other will disappear. So you can choose between all of them.
Reed, are you going to add to the first question?
Yes. Yes, I agreed with Marius. ScanFlow creates its own set of hanging protocol logic within MedDream's configuration framework. When a study comes in, ScanFlow's intelligent matching may be the option applied based on the radiologist's preference, and the existing manual rules are not deleted or replaced. Institutions do not need to change their existing setup to adopt ScanFlow. It's on a per radiologist basis.
Okay, thank you. I'm going to read the second question. If possible, add something related to mammo, tomo for comparison of different manufacturers' combination current prior.
Yes, as stated earlier on in the demonstration, ScanFlow works well with all sorts of imaging modality from X-ray, ultrasound, MRI, tomosynthesis, mammogram, regarding comparisons as well, and different manufacturers. That's the main crux of what ScanFlow deals with is different manufacturers create inconsistent labeling for the same sequence and regarding priors and currents. So ScanFlow can handle all of that on a per radiologist basis and per institution basis through our medical library.
Okay, thanks. I'm reading the next one. I want to learn more about ScanFlow.
At the end of this presentation, there is an email to the co-founder, Victoria Ellison, and all emails regarding wanting to learn more about ScanFlow can be directed towards her, and we can have follow-up conversations.
Okay, thank you. Another one. Does ScanFlow analyze pixel data?
Yeah, this is a great question. And ScanFlow does not utilize pixel data. We work entirely through DICOM metadata. So ScanFlow runs on a CPU infrastructure, and there's significantly less data processing, which keeps the solution lightweight, fast, and avoids any regulatory processes associated with image analysis. Also, because of this, we're not hindered by any artifact that may be on the image, whether it be from patient motion or metallic artifact, etc.
Okay, thank you. The next one. How does ScanFlow handle edge case?
Another great question, and one we get a lot. So during our implementation phase, we create an institution-specific medical library and of all the expected DICOM metadata specific to their scanners and their workflows. So this significantly reduces edge cases from the start. But whenever there is an edge case that breaks a radiologist protocol, we immediately update our institution-specific library so that that edge case will be correctly hanged moving forward. So it's a very fluid situation, and we're very aware that edge cases occur all the time for the radiologist.
Okay, so I can read the next one, yes? So we got a question during the webinar. I'm going to read them now. How will this work with comparison of studies? If I'm correct, the demo only showed current studies.
This will 100% work with comparison studies. That is the whole point of ScanFlow. We want to make sure that all the sequences are exactly where they should be, and all the comparison studies are where they should be as well. And doing the comparison studies along with MedDream, we'll be able to have all those comparisons exactly where the radiologist wants it every single time.
Okay, thanks. I'm reading the next one. Are other viewport configuration when 2-on-2 possible?
100%. We can do whatever configuration the radiologist wants. The reason we just kept it 2x2 is just to keep it standard and consistent, because this is a lot of radiologists like reading in this 2x2 configuration. But yes, the configuration is irrelevant for ScanFlow. We can make it whatever configuration you want. The main reason that these hanging protocols break are from inconsistent DICOM metadata. So whatever configuration you want, ScanFlow can easily make that possible.
Okay, thank you. What are known limitations of the solution?
This is a great question, and it's important to know whenever you have a product what the limitations are for a solution. And for ScanFlow, one of the main limitations that we're consistently working on is outside studies. So sometimes when a radiologist will read an outside study, there may be no DICOM metadata associated with that header. And this DICOM metadata sequence naming is really institution specific and where this information comes from. So depending on where this outside MRI came from, which institution, where that CT came from which institution. And once we recognize this limitation that is institution specific, we can make sure that we can figure out a way so when a radiologist pulls up an outside study from a different outside institution for a radiologist to read, that hanging protocol becomes consistent for that radiologist from that outside institution. I know that sounds complicated, but end of the day, we're very fluid. We recognize this limitation, and when it happens, we're going to make sure that we can make it more consistent for radiologists.
Okay, thank you. Next question. ScanFlow was available for enterprise, if I remember well. Mammo advanced tool like Quad Zoom is accessible on premium. So is ScanFlow available for premium also? It's related MedDream packages, enterprise, premium, and light. So Mars, maybe you could add on this, or we could
we should
later.
Yeah, we should check because in principle the ScanFlow integration is a separate thing, and to be honest, I'm not sure if we have agreed on which version it will go. So we need to check with the sales.
Yeah. Okay, so this we will add later after the webinar and our presentation. So I'm reading the last question. So if somebody else has more questions, please write them now. Or if you don't have them now, you can later contact MedDream, your sales accountant, or our partner ScanFlow directly. You see at the bottom our and their contacts. So I invite you to do so. The last one. Do ScanFlow change DICOM series description in DICOM files itself, or normalize series names provided by some external service for MedDream hanging protocols?
This is another great question. We do not change any DICOM series descriptions. We keep everything the way it is. We just organize it better, and we are able to recognize that this inconsistent label sequence matches the sequence that it's supposed to be, and then we can have a consistent hanging protocol. So we more normalize the series names through our protocol engine and through our matching system rather than changing the series name, and this allows us to be a lot more flexible. And again, this goes back to our whole institution medical library that we have. The whole point of the institution medical library is to be able to easily recognize all of the inconsistent labeled sequences that the radiologist faces so that they can have consistent hanging protocols.
Okay, thank you. So I think this was all the questions we got before the webinar and during the webinar. Thank you all for being active, for your questions. So this would be our using the moment to invite you to meet us in the upcoming exhibitions. So tomorrow, WH6 Miami, former FIME exhibition starts. MedDream will be first time exhibiting there. So I invite you to visit our booth. As I know, our partner ScanFlow also will be visiting, so take your chance. So I'm moving to the next slide, and for next month, for July, if you are not on your vacation, I also want to invite you to visit us in Agra, another exhibition. In this one, MedDream is exhibiting the second time. So I kindly invite you to visit our booth and continue the discussion and to see what we can do in the future. So this would be it for our presentation today, for our demonstration. Thank you for our guest speaker, Reed, for really interesting presentation and really informative. And also demo, I believe our attendees also thinks the same, and who could not be with us today during live webinar will receive the video recording of webinar and can watch it later. And of course, I invite you all to subscribe to our YouTube channel, where you can find all the integration webinars we've done in the past, to also watch this webinar, share with your colleagues if you want to rewatch them. And thank you once again for our guest speaker, Reed. Thank you for my colleague, Marius, and thank you for all the attendees. Have a good summer. See you in upcoming exhibitions, and of course in our upcoming webinars. In July, we plan to do a new release webinar. So stay tuned, see our news, and see you then. Thank you again.
Thank you very much. Bye.
Bye all.
Thank you very much.